Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So we have to determine y prime for each of the following. And we are given these three y functions. So let's start with the first function, y equals tan x plus cosine x squared. So for this function, we'll have to use the chain rule to find the derivative because this expression has an inner function tan x plus cosine x and the outer function is this square function. So as per the chain rule, we start with the derivative of the outer function. So we have to use the power rule for the outer function. So we'll move the exponent 2 to the front of the term and we'll subtract 1 from 2 in the exponent. Times the derivative of the inner function. So in the parentheses, the derivative of tan x is secant square x and the derivative of cosine x is minus sine x. Now we can simplify this expression. Now in the exponent, 2 minus 1 is equal to 1 and we don't write 1 as an exponent. So it's just parentheses tan x plus cos x times. Now in the second parentheses, the secant square x will stay the same and plus minus sine x will become minus sine x. So this should be the final answer for the derivative of the first y equation. Now we can analyze the second one. So we are given y equals sine cube x times tan x. Now this expression is made up of two types of functions. One is the sine cube x and tan x, and sine cube x and tan x are being multiplied. So we'll have to use product rule to find the derivative of this y equation. Now sine cube x can also be written as so we can put the cube on the sine x. So we'll have to use chain rule to find the derivative of sine x cube. So we'll use product rule and chain rule. So we'll start with the product rule. So as per the product rule, we start with the derivative of the first function and the first function is sine x cube. So we'll have to use chain rule to find the derivative of this function. So we'll start with the outer function, which is the cube. So we'll use the power rule to find the derivative of this cube. So as per the power rule, we'll move the 3 exponent 3 to the front and we'll subtract 1 from 3 times the derivative of the inner function, which is sine x, and the derivative of sine x is cos x. So this is the derivative of the first function times, now we are using the product rule, times the second function plus the first function times the derivative of the second function, and the derivative of tan is secant squared. Now we can simplify this expression. Now in the exponent, 3 minus 1 is 2. Now we can simplify this expression by breaking down tan into sine over cos. Now sine x cubed can also be written as sine cube x. Now we can simplify it further. Now sine x squared can also be written as sine square x. And then cos x and sine x over cos x, we can cancel out the cos terms. So we are left with just sine x. So the second part stays the same. Now in the first part, sine square x times sine x is sine cube x. Now we can factor out sine cube x from both terms. So we are left with 3 plus secant square x. So this should be the final answer for the derivative of the second y equation. Now we can analyze the third y equation. Now the third equation is y equals e to the power tan of square root x. So there is an exponential term with the base e and the exponent is tan of square root x. So the first step here is to change this radical or the square root on x to rational exponent 1 over 2. So this will make it easy to find the derivative of this y equation. Now we'll have to use chain rule to find the derivative. So we'll start with the derivative of the exponential function. So we know that for an exponential term with base e, the derivative is the e term itself times the derivative of the exponent. And the exponent here is tan of x to the power half. Now this tan term is a composite function because it has an outer function tan and the inner function is the x to the power half. So we'll have to use chain rule to find the derivative of this exponent. So we'll find the derivative in the next step, and in this step we'll just show that we have to find the derivative of this composite function. So we use this prime to show that we have to find the derivative of this tan term. Now in the next step, we can use chain rule again. So the e term will stay as it is. Now we'll start with the derivative of the outer function, and the outer function is tan, and the derivative of tan is secant squared. Times the derivative of the inner function, which is x to the power half, and for that we'll have to use power rule. So as per the power rule, we'll have to move the exponent half to the front and we'll subtract 1 from half. Now we can simplify this expression. So in the e term, so we can change the rational exponent half back to square root. And we can do the same in the secant square term. And now in the exponent of x, half minus 1 is negative half. Now in the next step, we can move the x term to the denominator to make its exponent positive. Now we can change this exponent half to square root on x. Now we can move this fraction 1 over 2 square root x to the front of the term. So this should be the final answer for the derivative of the third y equation. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.